Welcome to the new session of the course of differential equation. In this session, we will discuss about the initial value problem and boundary value problem. In the last session, we discussed it is that we have the homogeneous second order linear differential equation as y double dash plus p of x y dash plus q of x y is equal to 0. See, here maybe we can find out two linearly independent solutions as y1 and y2. Two linearly independent solutions of equation number 1, this homogeneous linear second order differential equation y1 and y2. Then we say that c1 y1 plus c2 y2, c2 y2, sorry, c1 y1 plus c2 y2 is the general solution. General solution of the differential equation 1. Okay, if they are linearly independent and this, if they are linearly independent, this is called the fundamental system or the basis of the given differential equation y double dash plus p of x y dash plus q of x y is equal to 0. That we discussed just before. See, my dear students, so our discussion it is that c1 y1 and c2 y2, y is equal to c1 y1 and c2 y2 is the general solution of given differential equation, homogeneous linear differential equation. There c1 and c2 are the arbitrary constants. That means they have a capacity as like a variable, they can choose the values as their own wish. See, our thought it is that how can we find a particular curve or a particular solution for a linear second order differential equation, homogeneous differential equation. So, from that thought we understood it is that if we provide some condition that may called the initial conditions, with that is if this one consider a problem like that, y double dash plus p of x y dash plus q of x y is equal to 0 is our equation 1, second order linear homogeneous differential equation, with the condition y of x naught is equal to y naught and y dash of x naught is equal to y1. So, if we apply these two initial condition, with this condition we call this problem as initial value problem, simply we call it as IVP. So, with the initial condition where x naught is the initial point on the interval I, where y1 and y2 are defined, where y1 and y2 are defined, where y1 and y2 are the two linearly independent solution of the homogeneous linear second order differential equation. Okay, so in this case we are able to get a particular solution for a differential equation. So, we will get while applying y of x naught equal to y naught and y dash of x naught equal to y1 in the general solution y is equal to c1 y1 plus c2 y2, we will get a particular value for c1 and c2. Similarly, we can say that if this one the boundary value problem, or simply we call it as BVP, boundary value problem. See, we have the second order linear differential equation y double dash plus p of x y dash plus q of x y is equal to 0 is our second order linear homogeneous differential equation, and suppose y of a equal to some k1 and y of b is equal to some k2, y of a equal to some k1, y of b is equal to some k2, where a and b, are boundary points of I where y1 and y2 are defined, where y1 and y2 are defined. See, this kind of problems are called boundary value problem. Y double dash plus p of x y dash plus q of x y is equal to 0 if y of k a equal to k1 and y of b equal to k2. We can apply the y of a and y of b in the general solution. Y is equal to c1 y1 plus c2 y2, where y1 and y2 are basis of a differential equation, where y1 and y2 is the basis of a differential equation. This is the general solution. So, by applying these two conditions in this general solution, we can find a particular value for C1 and C2. So, that is that we are able to get a particular solution in the case of boundary value problem also. So, we can discuss these concepts with two examples. In example 1, we will discuss. In example 1, we will discuss it is that consider the initial value problem, solve the IVP, y double dash minus y dash, y double dash minus y dash, y double dash minus y dash minus 2y is equal to 0 is the homogeneous part, and with the initial condition y of 0 equal to 4, y dash of 0 equal to 1, y of 0 equal to 4, y dash of 0 equal to 1. This is our differential equation 1. Say y is equal to y1 is equal to y1 is equal to y1 is equal to e raised to minus 6, y1 is equal to e raised to minus 6, y2 equal to e raised to 2x, y2 equal to e raised to 2x. Form a fundamental system of solution. Form a fundamental system. Fundamental system of solution on the interval. Okay, fundamental system of solution in a particular interval where y1 and y2 are defined of a differential equation. Say dear students, here it is given that y1 is equal to minus 6 and y2 is equal to 2 e raised to 2x. Sorry, y1 equal to e raised to minus 6 and y2 equal to e raised to 2x are the fundamental system. That means they are the basis. They are the basis. They are the basis of the given differential equation. Okay, fine. Since they are the basis of the given differential equation, we can say that they will satisfy the differential equation. So, this will satisfy the differential equation, and y2 equal to e raised to 2x is satisfies the differential equation, and also we can say that y1 by y2 or y2 divided by y1, y2 divided by y1 is equal to e raised to 2x divided by e raised to minus 6 is equal to e raised to, we can take e raised to minus 6 to here. So, 2x plus 6 is equal to e raised to 3x. E raised to 3x is not a constant. It is not a constant. Therefore, they are linearly independent solutions. Hence, that is the fundamental system or the basis. Okay, hence we can say that that is the fundamental system or a basis. Fine. Since they are fundamental system, we can say that therefore the general solution is y is equal to c1 y1 plus c2 y2. Y is equal to c1 y1 plus c2 y2. Therefore, this is equal to y is equal to c1 y1 is actually e raised to minus x, y2 equal to e raised to 2x. So, e raised to minus x plus c2 e raised to 2x. Okay. So, we have y1 dash to apply this differential equation, this one sorry, to apply the initial condition, we have the initial conditions y of, So, given initial condition y of 0 equal to 4 and y dash of 0 equal to 1, we have to apply the initial condition y of 0 equal to 4 and y dash of 0 equal to 1. See, dear students, y of 0 we can apply here y of 0 equal to y of 0 equal to 4 implies we apply y of 0 equal to 4. Therefore, 4 is equal to C1 e raised to 0. So, e raised to minus 0 plus C2 e raised to 2 into 0. Therefore, e raised to 0 is equal to 1. Therefore, we will have this is equal to 4 is equal to C1 plus C2. Okay. So, we found it is that C1 plus C2 equal to 4. We can take it, consider this as equation number A. Okay. Now, we can differentiate the given given general solution. So, y dash is equal to, we can differentiate y dash is equal to C1 into derivative of e raised to minus 6. Therefore, derivative of e raised to minus C1 into minus e raised to minus 6 plus 2 C2 e raised to 2x. Therefore, y dash will have y dash is equal to minus C1 e raised to minus 6 plus 2 C2 plus 2 C2 plus 2 C2 e raised to 2x. Okay, plus 2 C2 plus 2 C2 e raised to 2x. Okay. So, we have the second boundary condition is there, y dash of 0 equal to 1. We have y dash of 0, we have y dash of 0 equal to 1. We have y dash of 0 equal to 1. So, since y dash of 0 equal to 1, we can apply y dash of 0 equal to 1. Instead of y dash, we will have the value is equal to 1 minus C1 e raised to 0, that is equal to 1 itself, plus 2 C2 e raised to again we will have again 2 C2 e raised to 0, that is again equal to 1. Fine. Therefore, we found it is that C1 minus C1 plus 2 C2 equal to 1. So, we found we can write this as equation number B. So, we have two equations, C1 plus C2 equal to 4 and minus C1 plus 2 C2 equal to 1. From these two equations, we have to find the value of C1 and C2. Particular values for C1 and C2. So, we write C1 plus C2 equal to 4 is equation A and minus C1 plus 2 C2 equal to 1 is equation B. Okay. Minus C1 plus 2 C2 equal to 1, that is equation B. Fine. We can add A with B. So, A plus B equal to minus C1 plus C1 minus C1 plus C1 equal to 0 plus C2 plus 2 C2 equal to 3 C2 equal to 4 plus 1 equal to 5. 4 plus 1 is equal to 5. Okay. So, 3 C2 equal to 5, therefore, C2 equal to 5, C2 equal to 5 by 3. C2 equal to 5 by 3. C2 equal to 5 by 3. Say C2 equal to 5 by 3, you can apply the value of C2 equal to 5 by 3 in any of the equation A and B. So, put in A, put in equation A. So, while substituting, that is in equation A, C1 plus C1 plus 5 by 3 is equal to 4. C1 plus 5 by 3 equal to 4. Okay. So, therefore C1 is equal to, therefore C1 is equal to, therefore C1 is equal to, therefore C1 is equal to 4 minus 5 by 3. Okay, that is equal to 4 is equal to, we can write that as 12 by 3 minus 5 by 3. 12 by 3 is actually 4, 12 by 3 minus 5 by 3, that is equal to 12 by 3 minus 5 by 3 is equal to 7 by 3. Okay, that is equal to 7 by 3. Find the actually C1 equal to 7 by 3, C2 equal to 5 by 3. We found the value of C1 and C2. So, my dear students, actually the value is here. We have C1 e raised to minus x plus C2 e raised to 2x. So, the solution of particular solution of the initial value problem is, so therefore y is equal to C1 is actually, we found C1 equal to 7 by 3, 7 by 3 e raised to minus x plus 5 by 3 e raised to 2x is the 5 by 3 e raised to 2x is the general solution of the particular solution of the given initial value problem, is the particular solution of the given initial value problem. Okay, is the particular solution of the given initial value problem. See, my dear students, this may be useful in case of the initial value problem. Similarly, also we can find the boundary value problem also. See, instead of this one, as we discussed before, instead of this one initial condition, we just give the boundary condition also. So, we can write the solve the boundary value problem, solve the boundary value problem, y double dash plus y is equal to 0 with the boundary condition, y of 0 equal to 0, y of 0 equal to 0 and y of pi by 6, y of pi by 6, that is instead of 30 degree we use the pi by 6 is equal to 4, y of pi by 6 is equal to 4. That is, we are considering the interval 0 pi by 6, they are the boundary points. See, this we already discussed, it is that y double dash plus y is equal to 0, that we already discussed, it is that y is equal to cos x, y1 is equal to cos x and y2 is equal to sin x are two linearly independent solutions of y double dash plus y is equal to 0, y double dash plus y is equal to 0. As because they are two linearly independent solution of the homogeneous linear differential equation, we can say that this will form a basis. They are the fundamental set of solution. Therefore, their linear combination is a general solution. Therefore, y is equal to C1 cos x plus C2 sin x is the general solution. General solution of given differential equation 1. Okay, fine. Now, we found the general solution, because we already discussed about y1 and y2, they are the solutions of y double dash plus y is equal to 0. So, now we need to find the value of C1 and C2 by using the boundary condition. We have the boundary conditions y of 0 equal to 0 and y of pi by 6 is equal to 4. Okay, y of 0 equal to 0 and y of pi by 6 is equal to this one, y of pi by 6 is equal to 4. Okay, apply the boundary conditions, apply the boundary conditions, apply the boundary condition. We have y of 0 equal to 0. Okay. So, y of 0 equal to 0. We have given y is equal to C1 cos x plus C2 sin x. Okay, C1 cos x plus C2 sin x. So, we have this is equal to C1 cos x, y of 0 equal to 0 implies this is equal to y of 0 equal to 0 equal to C1 cos 0 plus C2 sin 0. Cos 0, C1 cos 0 equal to 1, that is equal to 0 equal to C1 plus C2 sin 0 is this part will be 0, therefore 0. Therefore, we found C1 equal to 0. C1 equal to 0. So, therefore, y now is reduced to, therefore, y now reduced to this is equal to C1 equal to 0. C1 is identically equal to 0 always. So, this is equal to in this case C2 equal to in this context only C1 is equal to 0, C2 equal to this is equal to C2 sin x is there. C2 sin x is there. Y is equal to C2 sin x. Fine, here we have y is equal to C2 sin x. Now, apply the next condition, we will apply the next condition, that is equal to y of pi by 6 is equal to 4. Okay, we have given that phi of pi by 6 is equal to 4. Y of pi by 6 is equal to 4. Okay, fine. Therefore, since y of pi by 6 is equal to 4, we will have this is equal to y of pi by 6 is equal to 4 is equal to C1 cos pi by 6 plus sin pi C2 sin pi by 6. Okay. So, already C1 equal to 0, therefore, this part will be 0. This is equal to cos pi by 6 is actually root 3 by 2 is there, but C1 equal to 0. Okay. So, C2 sin pi by 6 here we have C2 sin pi by 6 is here. So, sin of pi by 6 is equal to 1 by 2. Fine. Therefore, this is equal to 4 is equal to C2 into 1 by 2. We can take this 2 to here, therefore, we will have the value of C2. Therefore, C2 equal to 8, C2 equal to 8. Fine. See, finally, we found it is that C1 equal to 0 and y is equal to C2 equal to 8. So, dear students, we have the solution. Therefore, the solution of given boundary value problem, the given boundary value problem is y is equal to C2 8 sin x, y is equal to 8 sin x. So, my dear students, here we found a particular solution for the initial this boundary value problem. So, this is actually the initial concept of the initial value problem and the boundary value problem. We already discussed and learned it is that in case of a homogeneous linear differential equation, if there is two linearly independent solutions are there which are defined on a particular interval I, then we can say that there that two solutions y1 and y2 will form a basis or fundamental system, and that two solutions with that two solution y1 and y2, we can say that the general solution is y is equal to C1 y1 plus C2 y2. This here C1 and C2 are called the arbitrary constants. They have an efficiency to choose the value as their own wish. So, they act like a variable. So, if we apply the initial condition y of x naught and y dash of x naught, we will get the particular value for C1 and C2, or otherwise y of capital A, y of capital B, where A and B the boundary point of the interval I. So, in both the cases we will have the value of, we will get the particular value of C1 and C2. So, on that cases we can have a particular solution. So, in case of boundary value problem and initial value problem, definitely there we will get a particular solution for a differential equation. That is the very nice idea and concept of the initial value problem and boundary value problem, and we will discuss more problems in upcoming sessions. And in all cases, while solving the any kinds of the second order homogeneous linear differential equation, there all we can use the initial value problem and also boundary value problem also. Okay, thank you for watching these videos. Continue watching. Thank you very much.